This is an application example for a quadratic function in the general form. The marginal cost C, measured in dollars, of manufacturing X cell phones is given by this quadratic function written in the general form. How many cell phones should be manufactured in order to minimize the marginal cost? Because this is a quadratic function, we know that it's going to have a graph that's a parabola. And because the leading coefficient is greater than 0, we know that that parabola is going to be opening up. So without getting too detailed, let's just picture what this parabola might look like using a concept drawing. The horizontal axis, X, is going to represent how many cell phones are manufactured, and the vertical axis is going to represent the corresponding cost for manufacturing X cell phones. Since we're being asked to find the minimum cost, that means that we're being asked to find the minimum Y value, or the minimum output value, which occurs at the vertex. When we have a quadratic function in the general form, we calculate the vertex by first calculating the x-coordinate negative b over 2a, and then plugging that x value back into the function to determine the corresponding y value. So we're looking for that vertex point, and we start by calculating x is equal to negative b over 2a. Again, a is the coefficient on x squared, b is the coefficient on x, and c is the constant. So negative b is going to be negative 100. Divide that by 2 times a is 1/3, and then we simplify. We have positive 100 in the top. 2 times 1/3 is 2/3, and when we divide fractions, we keep the top, flip the bottom to be 3/2, and change it from divide to multiply, or we can also say that we multiply by the reciprocal of the denominator. Let's drop a 1 under that 100 so that we can more easily see that the 2 cancels into the 100, leaving 50, and then 3 times 50 in the top is 150, and 1 times 1 in the bottom is just 1. So the x-coordinate of our vertex point is 150, and now we need to calculate the corresponding output by plugging 150 into the cost function. So the cost function evaluated at 150, let's copy our cost function down, and we leave holes for the independent variable x. This helps us to be more accurate with our signs. And then we plug 150 into all of the x variable spots. And now we simplify. 150 squared is 22,500, minus 100 times 150 is 15,000, plus 9650. 1/3 times 22,500 is 7,500, minus 15,000 plus 9,650 turns out to be 2,150. Our cost is measured in dollars, so let's go ahead and put dollars down there. So now let's complete the vertex ordered pair since we know what the corresponding cost value is, and then we can answer the questions. How many cell phones should be manufactured in order to minimize the cost? The minimum cost occurs at the vertex, and the number of cell phones manufactured that minimize the cost is 150, the x-coordinate of the vertex. So we'll clearly state our answer up here, 150 cell phones. And then what is the minimum marginal cost? The minimum cost is the y-coordinate of the vertex. So to answer that question, we'll say that the minimum cost is $2,150.